5. Trig equations. Trigonometric equation is an equation that contains a trigonometric expression with a variable such as sine of x. All right, so for this one, what we're going to do is we're kind of going back to our algebra days here a little bit. We're solving for x. All right, the difference being some of these ones are going to be a little tougher because you have to take into account the different properties that we have for sine, cosine, tangent, those types of things. Okay, the first two I think are probably the harder two of the crew, but I think we'll be all right. Now, one thing I would say is pull your unit circle out. Pull your unit circle out here somewhere. Give you a second to do that. Yep. All right, so here we go. First one. First thing, let's talk about finding all solutions of a trig equation. So sometimes we're going to be given these with no restrictions like we are in the first two here. Other times we'll be given ones that has to be fit in this interval. Usually the interval is from 0 to 2 pi. Okay. Now, these ones here in general are going to be with no restrictions on it. We have to take something into account. Remember, like the sine wave or cosine wave, it goes up and down like this, right? And it just keeps repeating over and over and over again. All right, so one thing we have to take into account is this. If we have x is equal to an angle, okay, we're just going to call it theta. If it's equal to an angle, then do you remember a period, how much of a period is for sine and cosine? Standard, just sine of x or cosine x. What's the period on that? 2 pi, okay? So every 2 pi, I'm going to be back at the same value again. Agreed? So every 2 pi, I'm going to be back at the same value. So any value that I get here, I'm also going to have 2, and I'm going to put an n times pi on theta. Because if I add 2 pi onto the original one, I'm going to have the same answer. If I add 5 times 2 is 10 pi. 10 pi would be the same answer, and so on and so forth. Does that make sense? So we have to take this into account here when we're working on something that has no boundaries, like we do in these first two. All right, so that's kind of a tougher concept to look at, but it's repetitive, so we just have to take this into account, 2n pi. All right, so first one, when we're finding a solution to trig equations, first thing you want to do, isolate the function on one side of the equation, then solve for the variable. Okay, just sounds just like solving for x back in algebra days, right? All right, so first one, we have 3 sine of x minus 2 equals 5 sine of x minus 1. So let's get whole numbers on the right, trig functions on the left. We good with that? So if I subtract 5 sine of x over, what's 3 sine of x minus 5 sine of x? Negative 2 sine of x, correct. If I add that 2 across, what do I have? Okay, so I have negative 2 sine of x equals 1. Now that 2's out front, so I'm good to divide here, right? Just remember, if the 2's with the x, I can't just do that. 2's out front, and I can divide both sides by negative 2. So I have sine of x equals negative 1/2. With me so far? Okay, so now we have a negative 1/2 for sine. So take a minute, look at your unit circle here. Okay, your unit circle, your sine is your y value, correct? Okay, so start at 0, start working your way around, looking at your y values. Which y value is negative 1/2? 11 pi over 6. I agree with that one. Is there any other ones? What is it? 210, which is 7 pi over 6. Okay? So those are the two values that make that true. Correct? Now, those are the only two between 0 and 2 pi. Agree with me? Now, after we go around again, we're going to hit it again, aren't we? Okay, so our answer for this, we have two answers here. We're going to have two final answers. We have to take that into account. So we're going to have x equals 7 pi over 6 plus, like we said up here, 2n pi. And then we would also have x equals 11 pi over 6 plus 2n pi. And those two would be our final answer. Just like when we're factoring or something, sometimes you get multiple answers. So what this is saying is 7 pi over 6 works, 11 pi over 6 works, and all the multiples of that. Does that make sense? You guys with me? And the reason we have to do that is because it's within this, because there's no boundary. Okay, there's no 0 to 2 pi interval that we're looking at. We're looking at the entire universe of it. All right, you guys with me? All right, I want you guys to try that second one there. It's going to be very similar to this first one. I'll give you about 2 minutes here. All right, so what do I have to do to solve this guy? Subtract what? Yep, subtract the 3 sine from both sides. All right, that's going to give me 2 sine of x equals root 3, right? Now from there, I have to do what? Divide by 2. So sine of x is equal to root 3 over 2. Now you go around the unit circle. Where is sine of x going to be root 3 over 2? Pi over 3, and also 2 pi over 3. Agreed? Therefore, we have to plug it into that equation. So we have pi over 3 and all the multiples. And then we have 2 pi over 3 and all the multiples. You only have to do that when there's no restrictions, correct? When there's restrictions, it makes it a little easier on us because we can actually get true answers. All right. Now, just while he asked that, if this problem had a restriction of like this, less than x less than 2 pi, then this is our final answer. We're done. Okay. But because there's no restrictions, then we have to make it work for every case. All right. So it actually kind of gets a little bit easier here for the next ones. Well, sort of. All right. So this one here, I'm not going to lie to you, is probably the hardest problem we're going to do. This one is equations involving multiple angles. And when I say multiple angles, I mean something more than just x. Okay, here we have 3x. And like I said before, we can't just divide that 3 out, can we? All right, that's what we worked on, double angles, half angles, those types of things. We worked on that the last couple of days. It doesn't work like that. It's more than just multiplying them by 2, that kind of stuff. All right, so for this one, we have to basically ignore that 3 for a second. So my question is, where does the tangent of x equal 1 at on our, where does that equal 1 at on our unit circle? Pi over 4, wouldn't it? Okay. So pi over 4, and that's the first one. We're only going to take that first one into account. Okay. So tangent x equals 1 at pi over 4. Because if you remember, too, tangent only goes from 0 to pi. Right? That's the period for tangent. It's a little bit different. All right, so pi over 4 is that equation. Now, that means that 3x, the thing we kind of set aside, 3x is going to be equal to pi over 4. Kind of substituted there a little bit. We figured out what tangent of x was, where it was 1, and set that equal to 3x now. So now, we simplify that a little bit. And I'm going to throw on that n plus pi. Okay? The 2n plus pi, this was only for sine and cosine. Tangent, you don't have the 2. Okay? So I use the 3x from here, brought it here. I use the fact of this here to put there. All right, now I'm going to solve for x. So I can divide everything by 3, giving me x equals pi over 12 plus n pi over 3. Now here comes the problem. Remember I said before, if you have no restrictions, you're going to leave it as an equation, correct? If you do have restrictions, I want exact answers. Okay? So I have this equation now. If this is not here, I'm done. The fact is there. Now I need to figure out which of these multiples, which ones that I'm listing here, fit in that interval of 0 to 2 pi. Okay, I have that variable of n in there. So now I need to start plugging numbers in for n. So I'm going to plug in n equals 0. Okay, I'm just starting at 0. So if n is 0, now I have pi over 12 plus 0 pi over 3. That's just going to be what? Pi over 12, right? This is 0. Give me pi over 12. Is that in that range, 0 to 2 pi? Yeah. Okay, let's try n equals 1. My pi over 12 plus 1 pi over 3. I have to find a common denominator here, so I'm going to have pi over 12 plus, 4 pi over 12? Giving me 5 pi over 12. That still fits, doesn't it? Okay, so this one's good, this one's good. N equals 2. Pi over 12 plus 2 pi over 3. Common denominator. So I'm looking at pi over 12 plus 8 pi over 12. So that's 9 pi over 12. Still fits. Now, n equals 3. I'm just going to, for the sake of time right now, I'm just going to tell you that n equals 3 is going to be 13 pi over 12. N equals 4 would be 17 pi over 12. N equals 5 would be 7 pi over 4. And n equals 6 is going to be, I think it's 23 pi over 12. Now I'm going to stop right there. It's not 23, it's 25. 8 pi over 12. Back here at the beginning, I divided by 3. It's the same as multiplying by 1/3. Okay. So I go through here, and I wrote those out, and then I'm going to stop right there. 13 over 12, is that still less than 2 pi? Yep. About 17 over 12. 7 over 4. 25 over 12. No. So I don't have to go any further. I have 6 answers there. Those 6 would all fit in that range. Therefore, those would all be answers for that. Sometimes 2, sometimes 8. Honestly, when you go through it, this number right here, the bigger that bottom is, the more you're going to have. I mean, all right. Like I said, this is probably one of the toughest problems we'll do in here, just because of the series of plug it back in, plug it back in, plug it back in, plug it back in. Okay. Now I have a second one there. I'm going to say save that. Try that on your own sometime. I just want to keep going. I want you to see the different varieties of these. Okay. All right. Questions on that one? I think it's pretty straightforward. It's just kind of nitpicky. You know what I mean? It's just kind of tedious work. All right, let's look at the next one. Now this one here, we have a half angle going on, right? We have a half angle going on, same thing. We can't really multiply that 2 out, can't divide that 2 out anyhow. So we still have to take into account like we did on the last one. So looking at this one, I have x over 2. So I'm just going to kind of ignore that just like we did before. So when does the sine of x equal root 3 over 2? Look at your unit circle. When do we get root 3 over 2 for sine of x? Yep, pi over 3 and 2 pi over 3, correct. So last time we did this, we just set that aside, found the value, then plugged it into that equation, right? Do the same thing here. Now this is a sine function, so we still have the 2 that's with the n pi. So I'm going to have 2 equations. I'm going to have x over 2 equals pi over 3 plus 2n pi, or x over 2 equals 2 pi over 3 plus 2n pi. Okay, and I just took these two, plugged in that original equation I gave you, set it equal to what my original angle would be. All right. Now I'm going to solve both of these for x. I'd have to divide everything by 2. No, not divide, multiply everything by 2. So I have 2 pi over 3 plus 4n pi. Second one, I multiply everything by 2. X is going to be 4/3 pi plus 4n pi. Okay? Now this is going to be a lot easier on us. Okay, it's going to be a lot easier on us because I can plug in n equals 0, right? If I plug in n equals 0 to the first one, the 4n pi goes away, leaving me with what? 2/3 pi, right? I can plug 0 into the second one. It's going to leave me with 4 pi over 3. Now, as soon as I put a 1 in, now I'm adding 4 pi to both of those, aren't I? I can't add 4 pi and still be less than 2 pi. There's no way, is there? Okay, I'm done. There's my two answers. That is going to be way more common than the tangent one, maybe. You get me? Okay, this would be a more common version of this. Questions on that one? Anybody? All right, let's keep rolling them. So those were ones where just straight solving, get a variable by itself type thing, isolate the variable, set it equal. Now we're going to move up a little bit higher order. Okay, these are going to be quadratic form, but I'm telling you, these almost get easier. They really do. All right, so trig equations in quadratic form. What do you want to do? You want to try to solve by factoring first. If that doesn't work, use another method such as the quadratic formula or the square root property. We're not doing the quadratic formula today, so you're lucky. All right, so for this one, I want to solve 2 cosine squared of x plus the cosine of x minus 1 equals 0, and this is going to be from 0 to 2 pi. All right. Question so far? Wait, that is the question. There can't be any questions, right? All right, so we're going to take this guy and we're going to factor it. If you look at it, we have it in that form, x squared, x whole number, right? So this is essentially just 2x squared plus x minus 1. If you ever need to do that and rewrite it like that, that's perfectly fine. Okay, and factor this. When I factor this, I'm going to have 2x minus 1 and x plus 1. Okay, that's how that guy would factor. All right, I just essentially ignored the cosine for a second. You all right with that? Bring it back into the fold. So if that's what it factors to, that just means I'm going to have 2 cosine of x minus 1 and cosine of x plus 1 equal to 0. Anytime we factor something has equal to 0, what do? Set each one equal to 0, right? So 2 cosine x minus 1 equals 0, and cosine x plus 1 equals 0. First one, I add the 1 across, then divide by 2. So I have a cosine x is equal to 1/2. Second one, I subtract the 1 over, cosine x equals -1. All right, this is easy now because I have just straight cosine x equal to this. Straight cosine x equals this. So go around your unit circle. Where's the cosine of x equal to 1/2? Should be two values. Pi over 3, that's the first one. Second one, 5 pi over 3, correct. Go around your unit circle. Where's cosine of x equal to -1? No. Cosine is your x value. So where's your x value? -1. I see one spot. Pi. Done. Okay. All right, you with me? I think that's way easier than those first ones, don't you? I mean, it's straightforward. It's kind of it's back to algebra, factor that puppy, set them both equal, and solve. All right, as long as you don't have like a 2x or something in there. If you have the 2x, then you have to set it equal to that equation with the pi, the 2n pi. But in this case, it's pretty straightforward. All right, let's do another one. So that was just straight factoring. Let's do one with square root property. So this one I have 4 sine squared of x minus 1 equals 0. Same restrictions. X is between 0 and 2 pi. Actually, all right, you guys remember the square root property? Square root property says if we have a square and only a square with our x, get everything on one side, or just that x term on one side, everything else on the other side, square root both sides. Okay? So this here, I'm going to add that 1 across. So I have 4 sine squared of x is equal to 1. Now I can divide both sides by 4. I get sine squared of x is equal to 1/4. Okay? Now, we can go ahead and square root both sides. I'm left with sine of x is equal to, what's square root of 1/4? 1/2. But square root property, you have to deal with plus or minus, right? Okay, so we have 1/2 and negative 1/2. That's my two answers for sine of x. Okay, go around your unit circle. Where do you have sine of x equal to 1/2? Pi over 6. Next one. 5 pi over 6. I don't think 2 pi over 3. Yep, you're looking at the x. And we're looking at y for our sine. Okay, so the 1/2, you'll find that in quadrant 1 and 2. All right, then quadrant 3 and 4, you're going to find the negative 1/2. What values are those? 7 pi over 6 and 11 pi over 6. There we go. Done. So those would be the value of x in that equation. Still good? Okay. Next one. Use factoring to separate two different trig functions in an equation. Okay. This one's pretty much the same as the one we did right before this. So we're going to look at tangent of x times the sine squared of x equals 3 tangent of x. Same restrictions, 0 to 2 pi. All right, so this one, let's try to factor this guy. And if we're going to factor it, let's get everything on one side equal to 0. Okay, so I'm going to bring that 3 tan of x over. I have tan of x sine squared of x minus 3 tan x equals 0. Now, can we factor that? We can factor some. Well, I think you're along the right side. But right now, they're not like terms because it's multiplied by sine of 2x, or sine squared of x. But there is a tangent in both of those, right? Just can't we factor it out? Yeah. Let's factor out a tangent of x. So we have tangent of x times sine squared of x minus 3. Now, is this in factored form? Yeah, everything's multiplication. There's no addition, subtraction, holding stuff up. We got one factor here, one factor here. So let's set them both equal to 0. Tan of x equals 0. And also sine squared of x minus 3 equals 0. Right? So tangent of x equals 0. Look on the unit circle. Where's the tangent of x equal to 0? We've got two values here. 0 and pi. Correct. All right. Second one. Let's add the 3 across. So I have sine squared of x is equal to 3. do the square root property again. So I have sine of x is equal to plus or minus root 3. Anybody see a problem with that? There's no root 3's, is there? Okay, there's no root 3's on the unit circle. Guess what? Boom. Answer. That was fun, wasn't it? Yeah. It's outside of the range, so it doesn't matter. Okay. You still have to check it, but as soon as you see, all right, root 3 is too big. Okay, we have root 3 over 2. Root 3 is too big. It's done. All right? Questions? All right. The next 4 are all. If we had no restrictions, then we're putting it back into that x equals the angle plus the 2n pi, or in this case with tangent, it would just be n pi. Okay. All right. Now these next series, I think I have like 6 of them listed here. Okay. They're all fairly similar. They're just using those formulas that we've used the last few lessons and kind of rewriting them here and there. Okay. So if we get through 2 of these, I think we're going to be in good shape. That's kind of my goal here. So at least get through the first one. First one's, yeah, you'll see. We have 2 cosine squared of x plus 3 sine of x equals 0. And we're going to have the same restriction. 0 less than or equal to x, less than, not less than or equal to, just less than 2 pi. I always want to put that equal to with the 2 pi. But. All right, so looking at this one, cosine squared of x plus sine of x. First thing I see that I don't like is I don't like the fact of I have 2 different powers of x and also 2 different trig values. See what I'm saying? Okay. Before, we could factor it if we had like cosine squared, cosine, whole number. We could factor that just old school. Here, I have 2 different trig functions. So I'm thinking, let's get this all in one trig function. Okay? So looking at this right now, that cosine, I can turn that into a sine pretty quick, can't I? Remember the Pythagorean identity? All right, so let's rewrite that as a sine. So that's going to give me 2, and then 1 minus the sine squared of x plus 3 sine of x equals 0. Now I'm in business, okay? Now I have everything in sines. So I have a sine squared, regular sine, and then I'm going to end up with a whole number when I distribute this. So let's go ahead and distribute. So 2 minus 2 sine squared of x plus 3 sine of x. I'm going to go ahead and rewrite the order here. I'm going to make it 2 sine squared of x plus 3 sine of x plus 2 equals 0. All right, I just reordered that to get it in that ax squared plus bx plus c terminology that we use for polynomials. Okay. Now, there is one thing I don't like about this. Any idea what the thing I don't like is before I try to factor this? I don't like that negative out front. Okay, I don't like that negative out front. Let's multiply everything by -1. That negative out front of your a term, that makes it a pain. Okay, so if I multiply every term by -1, now I have 2 sine squared of x minus 3 sine of x minus 2 equals 0. Okay, 0 times -1 is 0 still. So now I have it in a form that I like better. Again, if you want to rewrite this to the side as 2x minus 2x squared minus 3x minus 2 and factor it, you can go ahead and do that. Okay, that guy's going to factor with maybe 2x plus 1, x minus 2, I think. All right, so I can rewrite this in here with the functions. So 2 sine of x plus 1, and then sine of x minus 2. That's equal to 0. Now I'm to a spot where I can split this and set them both equal to 0. Okay? So 2 sine x plus 1 equals 0, and sine x minus 2 equals 0. All right, now let's just roll with both of them. So the left one, I subtract the 1, divide by 2, so I have sine of x equals negative 1/2. The right one, I take the 2 over, sine of x equals 2. Nice part is that one on the right, I have sine of x equals 2. Is that even a valid answer? No, because there's no 2's on the unit circle. Boom, that one's gone. So now I just have to take into account the sine of x equals negative 1/2. Okay? So from there, look at unit circle. Where is sine of x equal to negative 1/2? I see two values. 7 pi over 6 is 1, yep, and 11 pi over 6. Perfect. Done. Questions? All right. Do we have 2 minutes or 7 minutes? Just 2 minutes? All right, this is what I'm going to do. I'm going to stop right here. So